This problem is based on the work energy theorem. Let's try to solve the problem. A bike helmet, basically a shell of hard, crushable foam, is tested by being strapped onto a 5 kg head foam and dropped from a height of 2 meters onto a hard anvil. What force is encountered by the head foam in the impact if the impact crushes the foam by 3 centimeters? Okay. Now let us try to do the problem. This is the head foam. Okay. This is the head foam. This is the foam. Okay. This is the act. Now it is falling from a height of 2 meters. Upon falling, the foam gets crushed by 3 centimeters. 3 centimeters means 3 into 10 to the power of minus 2 meters. That is equal to 0.03 meters. So it gets crushed by this one. Okay. Here, what I do is, you know work energy theorem. According to work energy theorem, work done is equal to work done by the external force is equal to change in energy. Okay. So W is equal to delta E. Here, what is happening? Initially, the head foam has the potential energy because it is at a height of 2 meters. So I will write initially, energy initial is equal to EI is equal to UGI. Okay. And you know UG is equal to MGH. Okay. Now what happens when it falls through 2 meters? Then its energy, potential energy is getting converted into kinetic energy during the fall. By the time it reaches the ground, that means the reference point, the UGF again becomes 0. Okay. But I will let you know. And then you may be wondering, what about the kinetic energy? Kinetic energy is 0 because initially the object is at rest. And upon touching the ground, it will become, it comes to rest. Therefore, the kinetic energy will not come into picture at the initial position and final position. We are considering the initial position and final position. So initially, the object has only the gravitational potential energy, and upon touching the ground, it becomes 0. Okay. Now, we have to write down the work. What is the work done? Work done is equal to force times displacement. Okay. Here, what I do is head foam and earth as system. Okay, that also I will write here. Head foam and earth are the system. I consider them as the system. And then foam as the environment or surroundings. Now what happens when the head foam falls on the ground, the cushion or the foam gets compressed. Okay, so the compression is in the downward direction, whereas the force applied by the foam is in the upward direction. Okay, so one should be positive, another should be negative. Suppose if upward force you take as positive, the displacement downward side that becomes negative. Therefore, work done is equal to minus FD. Okay. Now, what happens? Or else you can take like this also. Work done is equal to, W is equal to F dot D, that is equal to FD cos theta. Am I right? And then here theta is equal to 180. Therefore, W is equal to minus FD. This also you can take. Okay. In whatever way you feel you can take in that way. No problem at all. Okay. Now, this is equal to change in energy. What is the change in energy? Delta E is equal to UG final minus UG initial. Okay, UG final is equal to 0. So I will write that one. Minus F dot D is equal to UGF. UGF minus UGI. Okay, just a moment. UGI. Now, initially, the head foam has the gravitational potential energy, and finally, it has 0. Now, what I do is, I will change the sign through and through, or else I will leave it like this. F dot D minus F dot D is equal to minus UGI, because UGF is equal to 0. Since UGF is equal to 0. Okay. Now, the minus sign goes off. You are left with F dot D is equal to UGI. Am I right? Now, what he is asking us, he is asked us to find out F. Therefore, F is equal to, what is UGI? MGH. MGH divided by D. Therefore, this is equal to, F is equal to mass. What is the mass of the object? 5 kg. So, 5 into 5 kg times 9.8 meters per second squared times 2 meters divided by 0.03 meters. Now, what is the answer for this one? 19.6 into 5 now. That is, am I right? So, 19.6 into 5 is equal to 98 divided by 0.03 is equal to 3266. Am I right? 3266. 3266.6 recurring. Okay. So I can rounding it, this will become 3,300 meters. Understood? Simple. You have to consider the work energy theorem, and then you have to choose the system and surroundings skillfully. Okay. Just I am considering head foam and the earth as the system, and then the foam as the surroundings, so that the work is done by the foam on the head foam, and then here that is 180 degrees, because the force is acting upwards and then displacement is acting downwards. So theta becomes 180 degrees. Therefore, W is the negative work. Negative work is done by the foam on the head foam, and then that is equal to change in energy. Here, finally, the object is coming to the reference point. This is the reference point. Earth is the reference point, or ground is the reference point. And then the head foam falls from a height of 2 meters. That is why the final energy, final gravitational potential energy becomes 0. And then initial gravitational potential energy is equal to mgh. Using the values, we just plug in the values, you get the answer. That's it. Okay. Thank you. Bye-bye.